Hi, and welcome to the Pre-Algebra Exit Ticket 32.3 video key. And we hopefully have gotten to some three-dimensional Pythagorean theorem work today, so this should be fairly straightforward. So we have an 8 by 6 by 5 rectangular prism. We want to go diagonally from this front corner to this upper back corner, diagonally across it three-dimensionally. Well, all we have to do is square this, and square this, and we get the square of the diagonal. So I'm going to call this x, y, and z. So x squared plus y squared plus z squared, so length, width, and height, is going to equal diagonal squared. Okay, and if we wanted just diagonal, you can say diagonal equals all of that and square root of all of that. Okay, so now let's figure out what all of that is. We're going to get the square root of, let's say 8 is x, so 8 squared, doesn't matter actually which one you choose, plus 6 squared plus 5 squared. Okay, and that's going to equal the diagonal. Okay, and then we start sorting out what those squares are. Square root of 64 plus 36 plus 25. And that's going to equal the square root of 125. And that's going to equal the diagonal. So the square root of 125, well, we can factor 125 is 25 times 5, so we can pull out a 5. 5 square root of 5 equals the diagonal. And if we wanted to know, and that's in millimeters, we wanted to know how, if we wanted to get that's an exact answer. Let me just spit it that way. So if we wanted an estimated or rounded answer, we can just calculate that. 5 times the square root of 5, put it into the calculator. Okay, so 5 times the square root of 5. Okay, 11.18-ish. Equals 11.18 millimeters rounded. All right, now we need to run a string of lights from the top of this tree to point A. So I'm going to draw that line. We're going to do a string of lights from here to here. Now it's going to sag a little bit, but we're just going to deal with it as a straight line, and then we can give it an extra meter or something like that to make up for that. Of course, this is if we put all this together, this is an imaginary rectangular prism here. And so we're just getting the diagonal of a rectangular prism. And so we're going to get x squared plus y squared plus z squared, and that will give us what we need. And that'll give us d squared. So d squared equals x squared plus y squared plus z squared. And so I'll just leave it like this. So that's going to equal 10 squared plus 9 squared plus 4 squared. And that's going to equal 100 plus 81 plus 16. So that's 181 plus 16, which equals 197, which is actually very close to a perfect square. The 196 is 14 squared. So we're going to get the square root of 197, which happens to be prime. If you want to look it up, you can. But it's going to be, okay, and that's the exact answer. Okay, and we can get the square root of 197. Clear that. Square root of 197, and it's going to be just a hair over 14. So you could actually round that to 14 and be good. Okay, estimated 14 meters. Okay, and that's square root of 197 meters. since we're actually measuring it. And honestly, practically, we would probably make it 15 or 16 meters to account for sag and any slack that we needed. And that's a good place to stop.